go ahead and this is the first two problems are very easy actually. So now let's go ahead and go back to the virtual machine. We'll do clear here, ls-l. I'm gonna create a new folder for this one. I'm just gonna call it RSA, mkdir, RSA. Yeah, yeah, RSA is fine. Okay, let's cd into RSA. Any questions, guys? No? All right. So, this is super easy, but again, I can use any of these scripts for the scavenger hunt, and so make sure you know how to use them. So the first problem had to do with just encrypting, right? So we did that first problem from the Word document, this one here. Um, Bob wants to communicate with Alice, problem one. So it all the way to here. And I provide the values, and we just need to see how that modulus operation works in Python because these things are not practical to do with a calculator. All right, so let's go back to the VM. Whoops. Here, I'm going to create now. I'm going to call this one toy RSA. You guys know that this, in fact, has a vulnerability for the first one, as we discussed on Tuesday, toy RSA. But the functions work here. So we need to have, and in this case, for problem one, it provides P and Q. So let's see it says we have the message M equals 7, P and Q. We have E and D, and we have the cipher C. Okay. So we just have to then do a few calculations, right? But we don't have to generate the keys. We have E and D. So there's only really one parameter, right, that we have to compute. Okay. So let's try it. So we're going to need, just like before, this is the exact same approach. We need an encrypt and decrypt function. So I'm going to do encrypt. Okay. And we're going to define that it needs some parameters. You might want to start labeling this as RSA. 1, 2, 3, 4. Return. Then I'm going to do decrypt RSA. Okay. And this also return. 2, 3, 4. Return. All right. So now we need to specify the parameters. So let's define it. We need a P and a Q. Need an N. We're gonna need an E. We need a D. And we have the plain text message M. Okay. And that's going to produce a C cipher. Okay. So that's essentially the logic. So let's fill in those values. So we know that M is 7, P is 5, and Q is 3. So P is 5, Q is 3, M is 7. Okay. Then we know that E and D here are 3. Obviously, that's not something ideal, but just for this first example, it's fine. So E and D are 3, right? Okay. There we are. So now let's define these functions. So C is going to be encrypt RSA. All right. Now we start defining the function here. So encrypt produces a cipher. So it should be do this in parentheses. So if you remember, it was M to the E modulus N, right? So that was the approach. So we need M. Now, something that is to the power of can be expressed with two asterisks. Okay. We also have some functions in Python, and in problem number 3, I will introduce those functions. But here we can just use the two asterisks. Okay, so this is going to be M to the E, let's say, right? And then the modulus operation should just be percentage. And then we need N, which is just P times Q. So P times Q, which if you remember, we covered this on Tuesday. Okay, so now these parameters need to be passed to this function. So I'm going to pass M, comma, E, and N. So if you notice, we've established an E and N are the public key. And so we're passing the public key in the message. So you guys should remember that. So now we go up here to encrypt RSA, and it's the same thing, M, comma, E, comma, N, just like that. Okay? And this should give us a value. So if we run this one, print C. Let's try this out. Control X, Y, enter. We run the first problem, toy RSA. Oh, yeah. So I forgot to return C. We have to return the result. Control X, Y, enter. 13. Do you guys see that? And I think that's what it was when we did the calculation by hand. So you have to look at the notes. Yeah, the cipher was 13 in the prompt. Okay, so now we need to reverse. We already know what the plain text message is, so we're just going to prove that we can reverse it. All right, so let's do that. Toy RSA. Now we need to define the function decrypt RSA. So I'm going to go over here. I'm going to say M decrypted, and this is going to be decrypt RSA, right? And once again, we need to define what we provide here. So let's take a look at the function. So I'm just going to say here M, because that's what we're returning. Okay. So our function here should be so if you guys remember, it was what? M is equal to cipher to the D modulus N, right? So we do here M, we do cipher, and again, put this in within parentheses. So cipher, two asterisks, and D, decryption exponent. And then this one should be modulus N, just like that. Okay? So now we need to provide the parameters for this. So it's going to be C, the cipher, D, and N. If you notice D and N, that tuple actually makes up the private key. All right, so we're providing the private key and the cipher text. We also need to provide these parameters here. C, comma, D, comma, N. So my two prime numbers. And we are going to then print M decrypted. Okay, which should be the result, which should be the original 7. Let's do Control X, Y, enter. And there it is, 13 and 7. So that's problem number 1. Any questions on problem number 1? Pretty easy, right? So problem number 2 is exactly the same, but with more realistic numbers. And keep in mind, those numbers are really tiny, but we'll see that how it changes in problem 3, where we start using, better functions, okay? All right, so there are no questions on problem number 1. Let's move on to problem number 2, okay? And implement this. All right, so let's read problem number 2. Using the code from problem 1, encrypt message equals 65 and calculate the cipher. Assume the public key is E equals 17 and the prime numbers are 61 and 53 and the decryption exponent is 2753. So this should be the values that we used from problem 2. Yeah. All right, so let's go ahead and do this one. So let's go back where you can just reuse the same script and we're just going to change the parameters. So you can see here the prime numbers are 61, 53, and these are prime numbers. Okay. The E exponent here is 17. And the D exponent is 2753. The plain text message is 65. Okay. All right. So let's go ahead and that's it. That's problem 2. So 2790 should be the encryption, which should be correct. Got it, guys? Any questions? All right, great. All right, so go ahead, please. Yeah, I mean, it's because I'm just using the same piece of code, right? It's the same equations. I just had 2 different problems. Yeah, of course. Yeah, of course. So this is what we did on Tuesday, where we wrote the equations on how to encrypt and decrypt. And here I'm giving you E and D, but in problem 3, we actually have to try to generate the keys. So that's going to be the next thing. But that one is a much more involved program, so it's going to take us a bit of that. Working on it. But yeah, so as you saw, the key idea is that it should give us this, 65 should encrypt to 2790. If you notice also the number becomes much bigger when it's encrypted. So we'll actually talk about this later also. Um, and then we were able to very quickly decrypt such a big thing. Good? Yeah. All right. So everyone, so I'll repeat this. So if you run this one, you should get 2790. That is your cipher. And then when you decrypt it, you get back to 65. And as you can see, this time I'm using proper E and D, and it works just fine. All right, great. So yeah, so we've done the first two problems of the homework. Now we can start with the more complicated one, problem number 3. And for that one, I provided the code. So you'll need to download it either from the GitHub, which I think it's there. I'll check, or I put it on Brightspace. But let's take a look. So problem number 3 is this one, right? So we've completed 1 and 2. Problem 3 says, now that you have completed problem 2, try using a more advanced implementation. Because of the complexity of the RSA algorithm, some functions are provided to you. For this problem, you will need the source code provided on Brightspace. You need to write the generate keys function, and then you need to use all functions available to generate the prime numbers, generate the keys, and encrypt and decrypt a message. Okay, so that's what we're going to do. So you want to start from this one here. This should be the code, and you want to be able to download it onto your VM. Yes. I'm gonna check right now. It might be there. Thing is, yeah, give me a second here. Yeah, there's several versions in there. So you can look at both. I'll just download both. All right, so let's go back to the virtual machine. Okay. So we're gonna download these to downloads essentially. So let's open downloads. Okay, I'm gonna go to downloads. All right, see, I have a lot of files here. I don't think, no, here it is. Yeah, so I'm gonna move this unload. All right, so that should be it. So now go to the GitHub. Go to the GitHub here. So go to the GitHub. Oh, all right, and then repos. Click on repos and find the cryptography one. There should be a folder in there called RSA, and just download The two, one of the both scripts actually, because they're a little bit different, but they both do the same thing. So should be under cryptography, right? This one here. Okay. And we're going to take a look in RSA here. All right, so I have two examples, RSA full code and Scratch RSA problem. This is probably also useful. Convert hex to decimal. It's something that we will need later. I think it's just like a Linux command. Yeah, you can see that here. So we'll need this later, but we're going to need when we have like when we look at the OpenSSL portion of this topic. Okay, and we have to convert. There's no what? Okay. Yeah. There's nothing in there? You have the file? I think you have to download it. I don't think it opens it in because it's code, I think they have a little and it didn't open.
I'm saying we could like the RSA file,
Uh-huh.
like nothing there.
Really? Yeah, let me maybe the way you downloaded it. So let me show you. Um All right, but anyway, I was saying about this, that's going to be pretty important. So don't forget, because this is going to be one of the things you need also. But here, RSA full code, right? We're going to try to download both of these. So this is the script as it should be. And then you download raw file. It should be this. Um, Save. Okay, so let's go to downloads. RSA full code. So we would have to navigate to that. I'm going to open up another terminal. ls-l, cd downloads. Okay. Plus plus dash L RSA full code. Okay, so this downloaded just the web. Did you guys, did some of you download this? Say you went to Brightspace. Usually this has a download button here. Not sure why it won't. Yeah, yeah. hmm This should work though. This is the, oh, okay. Okay. I got this one. Still it downloads that web thing. Anyway, we gotta download that. Hmm. Should be an easier way to do this. All right, so I guess the option is to do what you said, just downloading it in your local machine and then moving it there. Missing. Okay. Anyway, I don't know. Um, all right, well, we're gonna have to move it some other way and move it through the um either email it to yourself or hmm okay. Okay. hmm Bottom right here. hmm So download the file there and just move it. So wherever my desktop is, for instance.
Where's it?
Yeah, okay. All right, so then it's very handy. So I would download that file here. We'll go to the same place, cryptography, RSA, and we download these two files, RSA full code. Okay, that downloaded. And this one got downloaded. Okay. Now they are in downloads, presumably. Let's see. Downloads. There they are. Okay. So now I'm going to where I was here. Downloads. And this one and this one. And then what?
On the right side, you can go to whatever folder you want to put it in.
So just double click on something here. Okay. So I'll put them on the desktop. Here. And this one for RSA. So then what? The little check? Oh, this one. Ah, there you go. That's very handy. I didn't know that. All right, great. Uh, anyone that didn't know that, so you got a nice little tool. All right, so let's see if it worked. Okay. LS D CD desktop clear LS dash L CD fall clear LS dash L CD RSA. Okay, let's open both of them. Make sure we do have code in there. Okay, nice. Control X, and then the other one, Nano Scratch. There we go. They're kind of the same except for the main part. Great, thank you, Antonio. This was very useful. How did you start this process? You went to machine, you said, right?
Yeah, so
And then this, I can just close here. Okay, so you started at machine, file manager. Yeah, sign in that. Okay, very useful. Yeah, thank you. All right, well, we're set up to this point. Yes, please go ahead. This thing, what he just said. All right, Antonio. All right, so let's see. That's yeah, it's actually pretty useful. So machine, file manager. Are you all right? File manager. Then seed D's, and then open session. And then you would go to, I think, this is actually your home machine. So I went to users, user one, I think. And then I downloaded these to downloads. Do you see that? And this is essentially now on your machine, you would go to like the GitHub, download the files to download. So they would be here. So then Scratch and RSA, pick where you want them here, like in home, seed, desktop, and then this blue arrow and moves them. Does that make sense? All right, great. Thank you very much. All right, guys. So I think, yeah, it's almost 5:40. Um, we at least have the code, right? So at least we have the code for problem three. As I said, there's no rush on this one. We will start reading through it if you'd like, and then next Thursday, we'll spend most of our time on that piece of code, getting it to work. And this time around, we have to see how keys are generated and everything. So this is a very complete piece of code that will do everything for you, including generating prime numbers. Okay, very large prime numbers. All right. Okay. Yeah, so we can stop here for today. Have a good fall break, and I'll see you guys a week from today. Yep, see ya.
Thank you, Rico.
Yeah, you too. Thank you.